An exercise in analysis. Let theta be between 0 and 2 pi radians. We need to prove that the infinite series of cos n times theta is equal to a half. First of all, we can exploit Euler's formulas to represent cos and theta as an average of exponential functions. So it should be the series from 0 to infinity e to the power of I n theta plus e to the power of minus I n theta over 2. That's one important step. And then I can split the summation from 0 to infinity a half times e to the power of I n theta plus summation a half times e to the power of minus I n theta. 1 over 2 is a constant. I can take this outside the summation. So it's going to be 1/2 series from 0 to infinity e to the power of I n theta plus a half series summation from 0 to infinity e to the power of minus I n theta. We have two infinite series, so this can be written as e to the power of I theta and all of this to the power of n plus a half times the summation from 0 to infinity e to the power of minus I theta to the power of n. We can write the formula for infinite series explicitly, so it's going to be 1 over 1 minus e to the power of I theta, and the second term is going to be 1 over 1 minus e to the power of minus I theta. I can take a half to be a common factor, and I have 1 over 1 minus e to the power of I theta plus 1 over 1 minus e to the power of minus I theta. Now the next step is to have a common denominator. The numerator is going to be 2 minus e to the power of I theta plus e to the power of minus I theta. The denominator is going to be 1 minus e to the power of minus I theta minus e to the power of I theta and plus 1. So that's going to be a half times 2 minus, the numerator is 2 minus 2 cos theta, and the denominator is the same, 2 minus 2 cos theta. I can take 2 to be the common factor here, and inside I have 1 minus cos theta over 1 minus cos theta. Okay, so I have a half times 1 minus cos theta over 1 minus cos theta. Okay, now I need to check. I cannot simplify fully now because I have to check what this function is doing. F of theta is 1 minus cos theta. So f prime of theta is going to be, the derivative of 1 is going to be 0. So let's write it this way. So it's going to be, the derivative of cos is minus, with a minus becomes plus, it's going to be sine theta. Sine theta. We can draw a graph of the function, of the derivative of the function. We have 0, pi, 2 pi, minus 1 and 1. We know that this function oscillates between minus 1 and 1. Okay, so it looks like this. So that is going to be, the derivative is positive, greater than 0. So let me continue here f prime theta is sine theta. Positive when theta belongs between 0 and pi, and is negative when theta belongs between pi and 2 pi. We can make a table. We have theta, f prime of theta, and f of theta. We have 0 here, pi here, 2 pi here. My derivative is positive when theta is between 0 and pi, and negative between pi and 2 pi. So is an increasing f of theta is an increasing function here, and is decreasing function here. So when theta is between, we see what happens here. What is the sign of the function? From 0 to pi, function is increasing, so we have f of 0 less than f of theta less than f of pi. F of 0 is going to be 1 minus cos 0, so that's going to be 0. F of pi is going to be 1 minus cos pi, that's going to be 2. So my function is between 0 and 2, so it's bigger than 0 and less than 2. Is a positive function. And now let's take this interval from pi to 2 pi. F is a monotonically decreasing function. So I can flip this f of theta is bigger than f of 2 pi and less than f of pi. F of 2 pi is 1 minus cos 2 pi, so that's going to be 0. And f of pi is 1 minus cos pi, and that's going to be 2. So my function is between 0 and 2, is a positive function. So we go back here and we can simplify this, and at the end of the day we will just have equal to 1 over 2. Okay, this is to check that we can simplify and that the denominator doesn't have any problem. So I just define the function 1 minus cos theta and study the monotonicity, and then I study how this function here f of theta behaves, and then I can simplify and I get 1 over 2. That is a nice exercise.